Hello, Honors Chemistry, and welcome to 2.4, where we talk about significant figures and math, right? So, in the previous section, we talked about how the number of digits any given measurement has is based on the quality of our instrument, right? An instrument that is more precise gives us more places, right? An instrument that is less precise gives us less places, right? So then if I were going to do some math after I took some measurements, right, either addition, subtraction, multiplication, or division, right, I am limited. My final answer cannot be more precise than my least precise piece of input. Yes, does that make sense, right? In that if one measurement comes from something that has so many significant figures, right, so many decimal places, but something was another measurement was lackluster and maybe only marked off to the ones place, right, I am limited by that one lackluster measurement, right, which is why it matters, right? That's why counting sig figs matters, right? So let's count some sig figs and make sure we're clear there first. I should have put a slide in here for that, but clearly I didn't. So first, let's just go ahead and count sig figs, right? So I think some are very easy, right? So first of all, anytime they're all numbers, they're all sig figs, yes? So this one has 1, 2, 3, 4, 4 sig figs. This one has 3 sig figs, yes? This one has 2 sig figs, right? This one has 1, 2, 3, 4, 5, 6 significant figures, yes? When they are all numbers, they are all significant, no question, yes? The only time that it gets to be a little bit fuzzy is if there are some zeros involved, right? And then we just need to be thoughtful about those zeros, right? So let's talk about decimal numbers first, right? So let's look at this value, right? I like to say that for a decimal, a measurement cannot begin until we get to a number, right? Until we get to a numerical something not zero, they're all placeholders, right? As in like this, and this all tell us about the relative size of this 5, yes? Which means that the only sig fig here is this 5, so this value has one significant figure, yes? Does that make sense, right? I did not put a lot of examples here, right? But let's do 0.023, right? So again, placeholder, significant. So this one has 2 significant figures because again, it cannot begin until we reach a measurement, okay? Let's do another one, right? Let's say that we were talking about 0.00000230000, right? So again, doesn't start till here, so placeholder, right? Then we have these 2 that count, right? And then now we might wonder about those. And the answer is yes, these are also significant. So we have 1, 2, 3, 4, 5 significant figures here, okay? Now, so again, zeros before a digit are placeholders. Zeros that come after digits and decimals, okay, that part's key. Zeros that come after digits and decimals are significant, right? Which means that if we look up here, right, this is 1, 2, 3 significant figures because this 0 comes after a digit and after a decimal, it counts, right? Likewise here, this 0 comes after some digits, after a decimal, it counts as significant, yes? All right, so zeros that are after digits and decimals are significant, okay? Zeros that are between digits, also significant, okay? Zeros that are between digits are significant, so this is 1, 2, 3, 4, okay? And then that just leaves us with numbers that are greater than 0, right? So let's say I have 1, 2, 0, 0, 0, right? Here in this case, right, we would just say that this is 2 significant figures and that these are placeholders, okay? For the same reason as those, right? In that these are not closed in, right? If I said this, then what that would mean, right, is that I hit that 12,000 mark and I kept on measuring and I am sure out to this place, which means that this would have 1, 2, 3, 4, 5, 6, 7, right? And if we think about our zeros rule, these are zeros that come after some digits and after a decimal, so they're significant. If these are significant, everything between them must be significant, right? Does that make sense, right? So this one has a boatload of sig figs. This one only has 2 sig figs. Yes, does that make sense? Okay. All right, and then scientific notation would be the last place where there might be some gray area, but the beauty of scientific notation is if we write it, it counts, right? So 1.2 times 10 to the third, 2 sig figs. 1.200 times 10 to the third, 4 sig figs, right? Sig figs are always a great way to express, scientific notation is always a great way to make sure that you are expressing the right number of sig figs. All right, now let's talk about how to take our ability to count sig figs and then apply that to the calculations we're going to do. Okay, so here, let's do multiplication and division first, right? So when we multiply and divide, right, what we're going to do is we're going to keep the least number of sig figs, right? That's the rule there, right? So what I'm going to do is I'm going to go through here and I'm going to find the least number. So this one has 3 sig figs. This one has 3 sig figs. This one has 4 sig figs. This one has, right, we said 1. And this one has 2, which means that my final answer can only have one significant figure, right? So if we go ahead and do that work really quickly, we are going to get 0.001078, right? And then we might wonder, well, how to round it? Well, this says round it to one significant figure, right? So if we're going to round this to one significant figure, let's go ahead and we'll go this one, right? Which means that this gets rounded to 0.001 as our final answer. Yes? Because this does not round that up, right? So it stays the same. That makes sense, right? Which means that that's a lot of rounding which happens, right? Which is why the accuracy of our measurements are important, right? Let's do another one. So this one has 4 sig figs. This one has 6 sig figs. So 4, 6, 3, which means we are limited to 3. So let's do the math. And we get 0.2038, but we have to round it to 3 sig figs. So 1, 2, 3. I'll use that fourth one to decide what happens here. So 0.0204 is my final answer. Yes? All right, next up we have addition and subtraction. When we add and subtract, right, it's going to be least number of decimals. Which is kind of easier, right? This one has 2, this one has 3, this one has 4, this one has 1. So I'm limited to 1 decimal place. Yes? That's what that tells us, right? Which means that my final answer, I'm going to round it to 1 decimal place, so 7.6. Likewise here, 3 decimals, 2 decimals, 3 decimals, so I'm limited to 2 decimals. So 2 decimals, so 131.11, because that 8 rounds that up. Yes? Note that in all of those scenarios, right, we wrote down a number first, right? So we wrote down what our calculator gave us with more sig figs than we needed, and then we did our rounding step, right? So anytime you do work, right, that's what you should do. You should write down what your calculator says, and then you should apply your sig fig and rounding rules, right? And then box your final answer, right? What that shows me is that lets me see that, yes, she did the math correctly. Her only error is in rounding at the very end, right? Which means a relatively small deduction, right? If you only give me this rounded answer, I don't know, because sometimes you guys, sometimes we make a mistake and we do a terrible job rounding. So then that leaves me in this situation where I don't know if you did the math wrong or just the rounding wrong, and if I can't tell, you're going to get docked for both of those steps being wrong, right? Does that make sense? All right. Then finally, right, we have these mixed math ones, right? So mixed operations, right? And then we're just going to go stepwise, and we're going to track our sig figs and round at the very end, right? So for example, here we have this addition and subtraction step, right? Which would limit us to 1 decimal, right? So let's do that, right? So 782.3 minus 451.88 gives us 330.42, right? But technically, I'm limited to this, right? And then I would take that number and multiply it by 3.897, right? And that whole answer is, because again, we're going to start by writing the whole answer, 1287.64674, right? Now, this has 4 sig figs. This, if we round it to the right number of places, also has 4 sig figs, which means that I'm going to keep my answer at 4 sig figs, right? So this is actually going to turn into 1288, and we would be done. Yes, does that make sense, right? Here we have this operation where it's division, so least number of sig figs, which would be 3. So 4.58 divided by 1.239 is going to give us 3.6965, right? And then we're going to subtract 0.578, which gives us 3.118529, blah, 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 right? But the fact of the matter is we have this value here, which we would limit to 3 sig figs, right? And then that means 2 decimal places versus 3 decimal places. So I'm actually only going to put 2 decimal places in here, right? Which means 3.12. Okay, so that is how we exercise our significant figures. And again, while this all just looks like, depending on how much attention you paid and depending on where you are in the sinking in process, right? It just looks like a bunch of nonsense and extra layers on your math. But again, don't forget that the reason we have these layers is because we are tied to the precision of our instruments, right? If we have a lackluster instrument that only gives us a little bit of information, our final answer is limited by that lackluster information, right? And that's why we do all of this, all right? No worries, you'll have plenty of practice, and you'll practice all year long. And I promise that by the time we get 2 or 3 chapters in, it will sink in and become second nature. And it won't be it won't require so much brain power, all right? But just keep practicing. All right, thank you for listening. Be good, and I will see you soon. Bye.